Okay, my friends, let's go through multiplying polynomials today, because I need y'all to start passing y'all GEDs. If not, I'm about to get fired, son. The last lesson was simplifying polynomials, right? We did stuff like the 2xy cubed plus 4xy cubed. There were obviously some that were longer. There were obviously some that were just an operation like this, right? And the way we did this was simple. We looked whether the terms were like, and if they were, we just did whatever the operation told us to do with the numbers. In this case, 2 plus 4 would give us 6, and then we would just bring down the like term. The thing I'm about to show you today is easy too. The problem is when you start mix and matching the two rules from these two different lessons, when you accidentally get too good at today's lesson and you forget all about this, and you start applying the stuff that you learned today to this, simplifying polynomials. That's where it gets tricky. So that is why you got to be doing not only today's lesson, but the lesson prior to this, simplifying polynomials, as much as you can. Look back and forth to each video, trying to memorize what rule goes to what lesson. So in multiplying polynomials, it's sort of the same but different. So like the one that we just did here, simplifying polynomials, whether you knew this or not, all it technically was adding and subtracting polynomials, right? So again, before you were doing this, right? Or it was this subtraction, but the only operations you saw in the lesson prior to this lesson, all the operations you saw was adding or subtracting. That's because simplifying polynomials, aka combining like terms, it's really technically just adding and subtracting polynomials. That's all it is. Today what we're going to be doing is multiplying polynomials. So how's that going to look like? If you recall, if we get the same terms, this is how multiplying looks like, right? It no longer looks with the dot, no longer looks like this, nor does it look like with an x. Obviously, because the x is used as a variable in algebra, not as an operation. So multiplying is symbolized via parentheses. So this is what we're doing today, is multiplying polynomials. Now, what's the rules here? Prior, whatever the operation was, remember, all we were looking for, we were determining whether the terms that we were given were like terms, which meant if they had the same letter and if those letters had the same power. And when they did, we just did the operation of the numbers. Multiplying polynomials, it's a lot simpler, but also a lot challenging. So whatever the case, whatever two terms are given, or three terms or four terms, it doesn't matter. They do not need to be like terms. You could multiply anything with each other. That's what makes this a little bit easier, right? So even though in this case the two terms are like terms, let's say I switched it up a bit. Let's say I decided to put I'll leave the x there, and I decided to put a squared here, and I'll leave that as the power of 1. These are no longer like terms, but it doesn't matter in multiplying polynomial world, okay? You could multiply any polynomial with each other. So now comes the question, how do you multiply? So this is what you need to do, my friends. The way we multiply polynomials is this. We no longer need to worry about whether it's like or unlike, so we just go straight to the numbers. We got one term there, we got one term there. Let's multiply the numbers first. In this case, the 2 and the 4. Let's multiply it. What's 2 times 4? You could get out your calculator. 2 times 4, 8. Don't have no shame on it. Please always use the calculator if you can. Always, always, always. And again, if you should be downloading that GED calculator, please go look at the video under the first module to see how to download the GED calculator on your computer. So the 2 times 4, the number part, creates 8. Then we move on to the variables, matching variables. So in this case, the 2 and the 4 created that 8. What we do is we chug along, kind of like a train, like a choo-choo train. If we're done with the numbers, right, we just chug along to the next item. In this case, a variable. So we go here, and what we do is we look at the other term, this term here, and we see whether we can find the same matching letter. In this case, yes, there's an X there. And what we do here is, this is where we differ from the previous lesson with adding or subtracting polynomials, aka combining like terms. Here, they don't have matching powers. Didn't matter whether they did or didn't, it doesn't matter. This is what you're going to do always. You're always, if you see matching letters, you're going to add the powers of those matching letters. You know this X is to the power of 1 because we went over that on the last lesson. If you didn't know that, well, now you know. Any standalone variable, any standalone letter is always to the power of 1. If you don't see a power up top, you must know it's a 1. So if we know that one is to the power of 1, if we know this X is the power of 2, just add those powers. What's 1 plus 2? Take out the calculator if need be. I don't care. We do 1 plus 2, and we get 3, my friends. So guess what? This X that we're bringing down is to the power of 3. That is how you multiply polynomials. Pretty straightforward, huh? Don't get too cocky, y'all. It's going to get a little challenging right here. Let's switch it up a bit. Let's make it a little bit more complicated. So let's say we have, 3, negative 3, X, Y, Z, 4, 2, 5. And we have, by the way, it might look like this. I'll explain that in a second. So it might look like this. They're not always going to be, I did that in the first example, my bad. It could look like this, or it could look like both in parentheses. It doesn't matter. All in all, whether they're 2 parentheses butted up with each other with terms inside, or just one that's butted up to the other, it's all going to be multiplying this whole term times this whole term. All right, so whatever. How do we multiply here? What about this term? Like I said, doesn't have to be like terms, so you're not looking for that. All we got to do is always start off with the numbers, multiply the numbers. What is the answer when you multiply the numbers? Well, in this case, I have a negative 3 times, oh son, I don't see a number. What's the number? Y'all should know this. We went over in the last video, an invisible 1. Right, in this case, it's a negative 1 because of that negative symbol that was already attached to the Z. But in between, there's a 1, so it's a negative 1. So ask yourself, what is negative 3 times negative 1? Boom, take out the calculator. Negative 3 times negative 1. Enter. Positive 3. Look at that. So we bring down the 3. We're done with the numbers. Now we focus on the variables. This is how we deal with this scenario. We got done with the numbers. We move along, a little choo-choo train. We move on step by step. We go by increments. We go by each term. Not each term. This whole thing is the term. We go by each little item within the term. So in this case, we move on to the X here, right? Ask yourself, do you see an X on this term? Do you see an X? Do you see an X? No. When you are given this situation, those are easy. You just bring them down to your final answer, X to the power 4. Chug along, move on to the next item. It's a Y squared. Do we see a Y here? No, we do not. So we just chug along, Y squared. We chug along to the Z. Oh, I see 2 matching Z's. What are you going to do in this situation? You add the powers. This Z to the power 5 plus this Z to the power 6. We get Z to the power of 11. And just like that, that's my final answer. Pretty easy, huh? Pretty easy. That is all you're going to need to be doing. Now, Are we done? No. Let's turn it up a notch. This is one form of multiplying. This is a one term times a one term. A monomial times a monomial is what they call it. But don't worry about the fancy words. Just know it's one term times another term. One polynomial times another polynomial. Let's go over something that's going to come across from this point forward in almost every lesson that we do. What happens when you're given a one term, a one polynomial, times two polynomials inside parentheses? This, my friend, is very unique. You're going to see this in algebra a lot. This is multiplying polynomials. It's the same thing. But this one in particular, when you see two terms, two polynomials inside of parentheses, and outside of that you see a term with no operation in separating it. When I say it's butted up, I mean it is butted up. Let's see this. If we were to get this and we were to move it to the side, and we were to put any operation in the middle of that, addition, subtraction, multiplication, oh, there's already a multiplication, division, or anything else like that, this would not be the thing that I'm about to show you today, right now. It's only when it's butted up like that in which you know this is a unique type of multiplication of polynomials. This is called distribution. This outside number we are going to distribute, aka multiply, to everything on the inside. And this is how we do these type of problems, because it's no different than the one polynomial times the one polynomial. It's no different. This is all we got to do, is just focus. We're going to do the same thing we just did with the one term times the one term. And what we're going to do is do it in steps. We are going to temporarily look at the last term, and we're going to temporarily erase it from our minds. Temporarily. And we're going to treat this as if it was another one polynomial times another polynomial. So we just multiply this to this the same way we did. Okay? So I'm going to bring this one back, but just know it's not there. We're not dealing with it just yet. We're going to do this times this first. And what do we get? Again, step by step, choo-choo train. 2 times 3, what do we get? We get 6. X, do you see an X on this term here? There it is, x to the power of 4. So what do we do in this situation? This x to the power of 1 times this x to the power of 4. We add those powers, and what do we get? X to the power of 5. We chug along. There's nothing here, but I do notice in this term here, there's a y there. We can't just erase that from our heads. No, we got to see this y. Is there a y here? No. We already know what to do in this situation. We just bring that one down. Done. These two have been multiplied. But then remember, I said we're temporarily didn't focus on that one. Now it comes into play. Now what you do, now that you got this done with that one, now what you do is temporarily erase this from your head. And now, just like before, we're going to do this 2x times the negative x now. So now we're erasing this one from our head, the one that we just got done. So let's do that. 2x times the negative x. Do the numbers. 2 times, what's the number? And 1, right? It's invisible, but it's there. It's specifically a negative 1. So you got to ask yourself, what is this positive 2 right there times this negative 1 that's hidden? It is a negative 2. And again, take out the calculator and do that if need be. Chug along. This x times this x. What do we get? Well, this x is to the power of 1. This x is to the power of 1. X to the power of 2. And just like that, my friends, you just distributed. That is your final answer. That is how you multiply a monomial to a binomial. That's the fancy word of saying it. Just think of it as when you see a one term attached outside of parentheses that happen to have two terms inside. This one's going to be extremely important to master, as it's going to be one of the most regular ones that we're going to come across from this point forward in all of our math. Okay, so there's that. Do you think I was done? We got another unique multiplying polynomial problem. This one is so unique that they gave it its own name. Well, the other one had its own name. It was distribution. This one was distribution. But that was just the action of multiplying from one direction to the other. That's just an action. This one has an actual name. It's FOIL. How does a FOIL problem look like? It looks like this. When you see two polynomials inside of parentheses multiplied by another two polynomials, and again, if you don't see any operation sign in the middle, the operation here is multiplying. It is all of this times all of this. These look so unique. You can't miss this on the GED test. By the way, you will be, and I repeat, you will be given this question on the GED. 100%. They'll just say, they won't say FOIL. They'll give you this problem right here, and then they'll ask you, simplify the following polynomial, or they'll say multiply the following expression or polynomial. Whatever it is, when you see this, you're going to be given 4 multiple choice options to choose from, or vice versa. They might give you this as the multiple choice options along with others that look similar to that. They might give you 4 multiple choice options, and the question would actually be the answer. They'll kind of reverse it. We'll look at that in a second, but this is straight from the GED, so let's do this. How do we solve this type of problem? And I'll explain why they call it FOIL, but I don't really want to think of the whole first, outer, inner, last. I want you to look at it like this. It is no different than what we just did prior, the distribution, and obviously that means it's no different from the very first thing we did, which is one polynomial times another polynomial. All we need to do, my friends, is get this first polynomial, the 2x, and we are going to multiply it with the other first term from that other parentheses. So what do we get when we do 2x times x? Like I said, all it is that very first lesson we did. It's just, you're just focusing on one term times one term, and you're just trying your best to focus on those ones. So it's the same thing. Just think of it as if it looked like this: 2x times x. If it helps, you could just rewrite it on the side of your notebook paper and just look at it like that. So just the only real hard part is memorizing what you need to multiply to what. So just remember, this first one you multiply with that first one. All right. So 2x times x, what do we get? We get 2 times 1, that gives me my 2. X times x, that gives me my x squared. Okay, what do we do next? Well, this is no different, like I said, from distribution. Do you remember what we did in this one? We did this outside one and we multiplied it to the 2 on the inside of the parentheses. We do the same thing. This outside one is the leader here. It's already multiplied to this first one. All you got to now do is multiply it to the last one, right? So 2x times -4. What do we get here? 2 times -4, that gives me -8. X times no x, easy peasy. Those are my favorite. I just bring them down. All right. Did you see what we did there? Are we done, Neo? No, we're not. There is still this 3 that we got to deal with. But guess what? It's the same thing, my friends. Think of it like this. Think of it as if the way we got this answer was by hiding this one, and we treated it like we did in this lesson, the distribution. This 2x, you multiplied it to everything on the outside. We sort of hid that little +3. That second term from that first parentheses, you kind of hide from it. And obviously we get this. But now that we got that, we hide the first one, the 2x, and now this is the ringleader, and we do the same thing. We distribute the +3 to the other two. And what do we get when we do that? So the 3 plus the positive 3 times x, what do we get? Well, ask yourself, what's 3 times the number? Always do the numbers first. 3 times the invisible 1, that gives me my 3. Was it a positive or negative? Well, positive 3 times positive 1 gives me my positive 3. Oopsie. Let's keep it the same color, why not? Then, same as before, the 3 times the negative 4. It's always that 2 distribution process that we do. Positive 3 times negative 4, that's easy. That's just a straight multiplication problem. There's no variables involved. There's no nothing. This is easy. It's negative 12. Neil, keep the same color, please. Boom, we just foiled. If you did not know this already, FOIL is just an acronym. First, outer, inner, last. So, I kind of shouldn't have kept this hidden. This was a 2x, I believe. Yeah. So, all it is saying multiply your firsts together. Then the first one you multiply with the outer. Then you do your inners multiplication. Then you do your lasts. The last one from this first parentheses and the last one of that parentheses. That's the last one. It's just an acronym to tell you what direction to multiply to what. Do I like that? No. What method I like teaching is what I just told you, is hide the second term from your first parentheses, then distribute, then go and hide that first term from your first parentheses and distribute the second term out. And then you'll get this long looking thing, which is technically your answer. I say technically, you know why? Because we're not done. Do you remember the skills that you just learned in the last lesson? Simplifying polynomials, aka adding or subtracting polynomials. It applies sometimes in multiplying polynomials, but just in math in general, lessons mix between the two. Like in this case, we were multiplying polynomials, but we get this final answer, which can be simplified even more using combining like terms. You must always be aware of this, my friends. You guys will get the wrong answer if you don't do this. What I should be always attentive of, I'm so stupid. Bloop. I really do apologize, y'all. Did you see here the 3 times the x? I said 3x. I know I did. I'm not that dumb. But I forgot to put the x. So hopefully y'all caught that. Hopefully y'all were like, why is it just a 3? My apologies. Remember, 3 times 1 gives me my 3. X times no x just gets brought down. X. My major apology. I gotta redo this whole video, but I won't because I don't got time. But yeah, so that x was supposed to be there. So yeah, sometimes your final answer can be simplified even more. Like in this case, the negative 8x and the plus 3x. Those can be simplified. Those are like terms. So now comes the real question. Do you remember how to combine like terms? You probably already forgot about the rules. You're like, do I add the powers? I forgot, what do I do? No, if you recall, you just do whatever the operation tells you. Negative 8 plus 3. What does that give you? That gives you a negative 5x, not an x squared. Remember, that whole adding the power is within the multiplying realm. This is the adding and subtracting realm, which you do not add powers. You just bring down the same like term. And then you bring everything else down, and this is your final answer. I really do apologize about that x problem. Hopefully that did not confuse you guys too much. But this is how you do your 3 multiplication problems. In the worksheet, it's going to be separated. Part A is going to be problems like these, the 1 term times 1 term. Then that was part A. Part B is the distribution, which means the 1 term times 2 terms inside of parentheses. And then part C is your FOIL. It's your 2 terms in parentheses times 2 terms in parentheses. Hopefully this was helpful. And yeah, any questions, obviously you guys got to message me. This is an important one. Make sure you master this.